Hello friends, a very warm welcome to the most happening event of today, that is one day workshop on IoT or Internet of Things. Now this today's event will definitely enhance your knowledge about embedded system, IoT, Arduino and its programming and how to do the interfacing, how to interface with sensor, actuators and make your own system. So starting from 10 a.m. till 5 p.m. you will get a lot of knowledge which I can assure you, if you attend all the sessions sincerely with full concentration, and please one thing, keep your pen and paper ready to write down the answers so that while attempting the test you may get nice score. So friends, for today's event what all things are needed? Very first thing, you should have your pen, paper and a concentration, and please keep earphones or headphones so that you can concentrate on what's going on in the event. Maybe some issue may arise because of internet, so please keep patience and cooperate, because in this lockdown period and all are working from home, so maybe there may be some delay or maybe some glitches because of this delay and the internet problems. So please don't move away, be here and try to enhance your knowledge. So what is today's event will take care? So in today's event there are 4 sessions, in which first session is on embedded system. Following to that there will be a session on IoT. After that there will be a test for 15 minutes which will evaluate you about the knowledge of IoT and embedded system. So these 2 sessions will give you some knowledge on which basis there will be a test which may be of which is of 30 marks and 60 questions will be there, and time duration will be only 30 minutes. In 30 minutes you have to attempt 60 questions. So please concentrate, nicely see the videos and wait for the test. Now after the test, that is post test, there will be 2 more sessions. One will be on Arduino and input output, and another will be application and interfacing. So my friends, are you ready with the full cooperation and sincerity? So what this today's session will bring change in you. So it will enhance your knowledge about Arduino, enhance your knowledge about IoT, enhance your knowledge about embedded system and programming. And this session or today's workshop is very nice for first year and second year student, because on basis of this they may design or they will be designing the project in third year. And students, and if you really want to enjoy with the project in third year, go with a project on IoT, that is Internet of Things. So not taking much of your time, I'll start with today's session, that is one day workshop on IoT, and the first session is embedded system. So the first session is embedded system. So friends, I hope you know what is microprocessor, what is microcontroller. So very fast I'll tell you what is the difference between a microprocessor and a microcontroller. A microprocessor is a single unit, processing unit, to which I have to connect memory, RAM, ROM, IO devices and anything to make a system. So alone microprocessor cannot do anything. So I have to connect the things and to make a computer out of it. So you might have studied 8085. So in 8085 I can make a small system that is called as a single board computer with 8085 with IO devices, with RAM, ROM and anything, and I can execute the programs on that. So that is what is called as single board computer. Now alone 8085 cannot be used. I have to have some subsystems. But on microcontroller it has a processor, ADCs, DACs, that is analog to digital converter, digital to analog converters, timers and all many things are integrated on a single chip. That is what is called as microcontroller, and microcontroller can also be called as single chip microcomputer. So microprocessor based system is called as single board, whereas microcontroller based systems are called as single chip. Now let's see what is embedded system and how this microcontroller plays an important role in designing the embedded system. So what is embedded system basically? So embedded system means it is 2 words, embedded and system. Now what is a system? So system is basically arrangement where all the different components are integrated, combined in such a way that they can do a specific task. Now take an example of a cycle. A cycle is a system in which there are two tires, one pedal, handle, seat and many things. Just imagine when I pedal, wheel doesn't move, then it cannot do any task. So I can't say that's a system. A system is in which all the different components or the different subsystems or all the different parts are organized in such a way that it will make some work. But then I cannot call that as an embedded system. This is only a system. A digital watch, your washing machine, your refrigerators are systems which can do some work. Like watch will give the time, the washing machine will wash the clothes, and refrigerator will make the product cool. So these are systems. Example of system where different subsystems are combined together, and combining together they can do some specific task. If they are not doing task, they are not a system. So I hope at this point you might have got cleared what do you mean by the word system. So once again, a system is an arrangement in which all the components or subparts are assembled, combined, organized for doing any task. But one thing, they have a fixed plan and they work with a set of rules. Now cycle will move only when it is being pedaled. Refrigerator will cool when it is given supply. And washing machine will wash when the clothes are put and it is turned on. So it has to follow some particular set of rules. If they are not following the rules, it cannot give any output. Now let's say, suppose if I pedal and wheel doesn't move. So it is not following the set of rules that when I pedal it should move. So a system will do some specific task according to a fixed plan and a set of rules. So that fixed plan is a task which it has to perform. Fine. So I hope the word system is clear. Now take an example of watch. Now what is the function of watch? Function of watch is to give the time. Now in this watch there are hardware, like different subsystems are needle, battery, dial, straps and everything. So what is the rule? That seconds clock should move every second. After exactly 60 seconds, that is 60 times, that is it is moving, the minutes hand will move by 1, and once the minute hand is moving by 60 times, its hours hand will move. That is what is the coordination of different subsystems. So you can see these are the different subsystems. You can see the different subsystems which are connected and do some specific task. But one more thing, that exactly after 12 hours, all the three hands should meet. Even that is also a criteria. Then it's a perfect watch. So watch is a system in which there are different parts which are connected together and they're working in a such a way that it will display time with some specific standard. Very important thing, it has to follow some standard too. That is what is the function of watch. Now let's see, we'll take another example, a washing machine. Now in washing machine, I have panel, I have switches, motors, control unit, water inlet, sensor, solenoid valve. Solenoid valves it to turn on and off the water. And what is the purpose of washing machine? That is to clean, rinse and dry the clothes. That is to clean, rinse and dry. This is the task. That is a fixed task. Now it has to follow a set of rules. That first of all it has to have a water inside it, and then I have to turn it on. Timer should be set, and after that it will start washing the clothes till that timer is going to 0, and then I have to put it in the rinsing tub. Now the thing is, the rinsing tub moves more faster as compared to your cleaning tubs. The job of cleaning tub is to clean the wet clothes and the dusty clothes or the bad clothes, and the job of dryer is, that is the rinser, is to rinse it out and make the clothes dry. So these are the functions. So it has to follow the set of rules that your dryer won't start till there is a proper inflow or a proper speed. Your cleaning system won't start if there isn't a sufficient level of water. So this is what is the things which a washing machine has to do. So washing machine has to follow some set of rules. It will start after the timer is on, and it will work till timer gets stopped. So this is what is a function of washing machine. Now, so I've told you all the different functions. Also one more important thing, that it should give me the indication of water level and overload conditions. Every possible thing it should give me the information. The next is refrigerator. Now the purpose of refrigerator is cooling and freezing. What are the subparts? Compressor, door switch, evaporators, temperature controller, condenser coils, fan, defrost timers, drain pans, and many more things are there in a refrigerator. So these are all subsystems which are combined together to make a refrigerator, and it is doing one fixed task, that is cooling and freezing. Now what are the rules to be followed? That cooling should stop when the low temperature is reached. So I have set a low temperature. Once that is reached, the cooling should stop. Now cooling should start as soon as the higher temperature is reached. So to start cooling if it becomes hotter. Now defrost, like after a specific time, it should be defrost, that the ice which is collected should be removed. Defrost water should be connected in a pan, that is a tray, and there is a door light. When I open the door, that door light should turn on. When I put it off, the door light should turn off. And if it is possible, if it's automatic refrigerators, it should display the present temperature inside and the scenario of the inside. So that is what is the different task of refrigerator. These are the rules which a refrigerator has to follow. So embedded is coming to the part system. All the three are clear to you. That is a washing machine, a watch, and a refrigerator. These three are systems. Now, when they will be called as embedded system? Then when they have some software which will run this hardware is on a microprocessor or a hardware. So when a software which is loaded in the hardware is called as firmware. Now take an example of a microcontroller. You might have studied 8051. In 8051, I write the program. So using my computer, I compile the code, and after compiling the code, I will write that code in the controller. And once I write the code in the controller, what will happen? It will start functioning. That is why microcontroller are mostly an embedded system, and that particular is called as firmware. You cannot write the code in 8085. So 8085 cannot be used alone in embedded systems. Now the second thing, if I take an example of watch, refrigerator, cycle, they are meant for specific tasks. The task of refrigerator cannot be interchanged with washing machine, and washing machine task cannot be interchanged with my watch or the refrigerator. So they are for dedicated, specific or particular task. And very important thing, they have to complete that task in a time frame. When I say washing machine, the timer is set, it will work for that. If I take an example of microwave oven, a timer is set for that. If I take a refrigerator, the cooling and that cooling and stopping cooling and start working of the cooling should be in a specific amount of time. So the main task is controlling. What controller does here? Controlling task. So in embedded system, there is a more task of controlling rather than processing. That is another difference between the general systems and the embedded systems. So I hope you might have understood what is the term embedded means. Embedded means it is included. So what is included here? A software is included in hardware, and this hardware is running depending upon that software, and the controller which is used does the job of controlling. That's why it's called as embedded system. So I hope the term embedded system is clear to you. So friends, let's move further. Now friends, till this point you may get questions on what do you mean by the word system, what are the rules to be followed, what is the criteria for the embedded systems, and many more things. So such questions may be there in the test. So please note down the answers for that. It will be really helping you. And friends, if you have yet not subscribed the channel, please subscribe it. Go and follow on the Instagram and also on Facebook with the name Kavedia Sir. So, and if you have not joined the classroom, please join it so that you can give the test. And after the 2 sessions, that is embedded and IoT session, there will be a test which will be of 15 minutes and 30 marks. So friends, let's move further in what is embedded system. Now embedded means it is defined as an electrical or electronic or electromechanical system designed to perform a specific, the word is specific, dedicated task in a fixed time, and it's a combination of hardware and software, that is firmware. So everything is coined here, that is, it is electronic or electromechanical system, and it performs some specific task in a specific time, and it should be a combination of hardware and software. If all these things are included, then it becomes embedded system. And generally microcontrollers are used. So in the next session, you will see when I connect that embedded system to internet, what happens. And to make this embedded system and the IoT, that is Internet of Things, what type of controllers, processors are needed in your third and the fourth session. So by end of the day today, you will learn about what is embedded systems, what is IoT, how to use Arduino and how to program that Arduino, how to take the data from the sensors and how to write it to the output devices. So all possible things will be given today to you. So friends, concentrate and sincerely attend today's session. And one more thing, once you complete this workshop and if you are scoring minimum 40% of the marks, you are eligible for an e-certificate. That will be really helpful for you apart from your knowledge which you are gaining. So let's see further what is embedded system. Now what says an embedded system, what different books or different authors says embedded system is. So as per the book, an embedded system is a computer based system for an applications or product which is dedicated software embedded in it. Dedicated means for fixed work, and it may be an independent system or a part of the subsystem or a part of a large system. So if I take a big system like assembly line system, now in an assembly line there will be different embedded systems connected. Now let's say a bottling plant, in a bottling plant also there may be a different sub parts, and each sub part may be an embedded system. Now take an example of a car. If it's an embedded system, in that there may be AC controlling, it's an embedded system. It may be the temperature controlling, that may be an embedded system. The wiper controlling, that may be an embedded system. So this different embedded system sub parts come together and they may form a big embedded system. Now what Todd Morton says, electronic system that contains microcontroller, microprocessor, but not general purpose computer. A computer is hidden on an embedded system. So there is no computer, keep that in mind. So Todd says electronic system that contains microcontroller or microprocessor. Microprocessor will work, but then the hardware will increase, but not general purpose computer. Because if I'm using general purpose computer, my system will become costly and unwanted cost will be arise because I need for some specific task, not for the general purpose task. So I can say the word computer is hidden, but instead of computer, there is a controller. And I've told you that in embedded system, controller is needed because controlling function is more than the processing function. Now what author Rajkamal says, an embedded system is one that has dedicated purpose software embedded in a computer hardware. Now what Van Wolf says, any device that include programmable computer but not self-intent to be a general purpose computer. So it has a programmable computer. So I can say, or your microcontroller, I have already told you it's a microchip or it is single chip microcomputer, and this is embedded with a software. So it does a work of computing, but a computing is small level and controlling is at more level. So it is not self-intended to be a general purpose computer. It is a computer which will do the computing, less computing but more controlling function. So let's see what others say. I hope these definitions are clear as per the textbook, as per Todd Morton, as per Rajkamal, and as per Van Wolf. Friends, now here you may get questions. So please note down. Now what IEE, that is Institute of Electrical Engineers, says, a general purpose definition of embedded system is that the device is used to control, monitor or assess the operation of equipment, machinery or plants. Again I am repeating, they are device to control. The very first word comes control, monitor and assess. Assist means they should follow some particular plan, some particular path, some particular set of rules, and definitely a time frame. Okay, so embedded reflects the fact that they are integral part of system. I've already told you the embedded system may be a part of a system, or it may be a big system or a small system. So in many cases, embeddedness may be such that their presence is fair from the obvious to the casual observer. Embeddedness means something which is included. So user won't think what is that included part in it. So I hope till this point all the definitions are clear to you. Let's move ahead. Now let's say different examples. So washing machine, refrigerator, microwave ovens, and all examples, all application has hardware and their subsystems. All application run on a software, that their hardware needs some software to run. all system has to complete a task in a specific time, and all systems are dedicated. So all these 4 points. Now friends, again here a question may arise for you. Hence, what I can say, what are the hardware, the component or subsystems? What is software? It is a set of rule, and dedicated, that is only one function in one particular time frame. So this is what is embedded system. So embedded system has a hardware component, that is a system or its subsystem, a software which is set of rule, and this software is included in a microcontroller inside a controller. So it will become a firmware and it has to do a dedicated function. Friends, see all these points. At every moment of point you may get a question. So keep track of what's going on. Now let's see what are the application of embedded system. So very first thing, embedded system is a computer system designed for specific purpose. Second, it has a processor, a controlling device, a memory and I/O, and also a communication device. Processor is a controlling device, and there should be a communication device which will take the data from the sensor, process it and give the information to the actuators or the output device. Then it has a integrated with physical process. So embedded system has to take the data from the physical system, convert it, and again it has to give back the physical system. Then only it will work as an embedded system. So take an example of car. Nowadays all cars are available with embedded systems. In that, those are microcontrollers. And India's very first bike, that is Hero Honda's Ambition. That Ambition was first embedded system bike. In that Ambition, AMI was called as Advanced Microprocessor Based Ignition or Advanced Microcontroller Based Ignition. So that ignition control was done with the help of microprocessor or microcontroller. That was the first embedded bike in India. So you have an assembly line in which the robots are there. So this assembly line is a big system. So small part can be the embedded systems. The next is the gaming consoles. The next is a cell phone. Alone cell phone itself is an embedded system. But when it is connected to internet, it becomes a part of IoT. And in that it functions like an object. The next are the different machinery systems. And finally you have an aeroplane. In aeroplane also there are embedded system. So why this aeroplane has an embedded system, or what are the function of embedded system in aeroplane? So in an aeroplane there are different subsystems. There may be pressure in the cabin, there may be the engine propelling speed and everything, every parameters, they are taken with a small embedded system, and there is a big controller or a big system which will coordinate with all the different parameters, and it will do the safe takeoff, landing and flying of the aircrafts. Now this is another example of embedded system. In this embedded system there is something which is called as ABS, that is anti-braking system. There is a gearbox, that is something information, climate control, motor control, all these are working together in coordination. So this ABS, gearbox, information, climate control, motor control, and all these are small subsystems. So they are connected with some bus or some communication means, and they can coordinate the function. Now let's say if there is a temperature. Now if temperature goes down, the AC may start. If AC may stop. If temperature goes up, the AC may start. That is one of the functions. Now suppose as there is a rainfall, wiper will start. Great. And when I take a turn in the fast speed, automatic anti-braking system will function, so that my vehicle will move very smoothly in the turn. And remember one thing, if you are driving a car and if it's an ABS system car, when you take a sharp turn, automatically braking is done. Now this braking is done with the movement of steering. The moment steering is moved, it applies internal brake. So car may not skid or roll off the road. So the next two applications are microwave oven and the washing machine. So both have their user interfaces. They both have their user interface. They both have the processor, some sensors and some actuators. So what are the actuators here? The actuators are nothing but, in a washing machine is a motor, and sensors are for water level and for timing and all the different purposes, and user interface is there for interaction with user. So this is one of the example of these both are examples of embedded system. Now this is a production system, where a big system where a small part can be an embedded system. Also you have a sensor network. This sensor network, there are sensors, you can see these are the sensors here, red color dots, These sensors can communicate with each other with some communication medium. Now in these sensors also there are microcontroller. Now there is something which is called as MEMS, micro electronic mechanical systems, nano electronic mechanical systems, NEMS and PEMS, pico electronic mechanical systems. So friends, I'll be putting a video on this also, or I may take one seminar in some few days on this topic also. So I hope you may be waiting for that. So what are MEMS, NEMS and PEMS? So here I can say these sensors are MEMS. Now this MEMS consists of a processor, a communication system, sensors, a battery, everything on a very small unit, and this small unit can be a size of a rice or a pulse. You can imagine what type of microelectronic it is. So these are spread, and once they are spread, maybe a humid atmosphere or hot atmosphere or a cold atmosphere, they will collect the information and pass it on to the server with the help of some sort of communication medium. So friends, don't miss out that video of MEMS, NEMS and PEMS. But one more thing, there may be a question here too. Now, apart from finding out the temperature, what are the different function of MEMS, NEMS and PEMS? So they can be used in a building to monitor the structural strength. So sensors can be put in the columns and they can take the parameters and they can find out the strength of the building. So if it is weak, then we can evacuate the people earlier before it collapses. Second thing, it can be used in disaster management. Third thing, it can be used in the forest where there is a breakout of fire and we cannot get the way to get inside. So they may help in getting inside that fire, which is a safe way to go inside so that the fire can be controlled. And many different such things can be controlled with the help of embedded systems. And one more thing, when this embedded system is connecting to internet, it will become Internet of Things. Friends, again, your communication system is an example of embedded system. Your wireless LAN, your routers, then all the communication devices which are automatic are part of embedded system. So embedded system finds application in biomedical, like your ECG recorder, your glucometers, or finding the blood pressure, and then in communication system like pagers, cell phones, cable TVs, all are a part embedded systems. Peripheral controllers like your keyboard controller. Now friends, in your keyboard there is a microcontroller. Now in a mouse also there is a microcontroller. Then a DMA controller, printer controller, your LAN controller, hard disk controllers, all are examples of embedded system. Then coming to the next, that is in industrial automation, process controller, DC motor controller, robotics, CNC machines, all this comes as a part of embedded system. In a scientific systems, there is digital storage systems, CRT controllers, spectrum analyzers, logic analyzers, CROs, function generators, all are part of embedded systems. Coming to entertainment, your television, video games, DVD players, recorders, and in defense, missile guidance system, and in your movement or in vehicles, you can take automatic cars or even the aircraft are part of embedded systems. So it's a big list, lot of list of the embedded system. You can see one by one what all these are, and this even the diagram, it helps you in recognizing. So there are music players, your dish antennas, these are PDAs, writing pads, yeah, examples of an embedded system. A digital camera is an example of embedded system, and nowadays these cameras can be connected to Wi-Fi also. So sometimes it may also happen that you come home, there is a embedded system as a television set, and that is your camera. The moment you come near the television, it starts displaying all the pictures which you have shooted with that camera. So how like a pleasant it is that one fine day you come with an event with your family members at home, and the moment you keep the camera and it starts rolling the photographs, so we can memorize what as the moment, and you can imagine what will be the feeling at that particular moment of time. So your embedded system, apart from controlling healthcare, every possible thing, it can even enhance your feelings too. I hope this much you are clear with. So this big list can be a questionnaire for you. Got it? Now coming to the block diagram of embedded system. Now embedded system has some input devices. There is a processor, then there is a memory, timer, serial communication, interrupt controller, parallel port, output circuits, there is a power supply, and some system specific circuits. Now friends, this complete block diagram, if I am going to explain here, it can become again one more video. So I'll be coming up with one video only on what are the different blocks of embedded system. So just for a right time being, you can say input devices are the sensors which are giving information, and to make it compatible with the controller, I have to use driver circuits. Now, one of the example of driver circuit can be analog to digital converter, because my sensor may be analog and my controller needs the digital information. So I have to convert analog to digital. And output circuits may be your relays, or it may be motors, or it may be solenoids, it may be displays. So when microcontroller output is given to these devices, there may be some driver circuit needed again to maintain the compatibility. Now there are some system specific circuit. System specific circuit means it's not always necessary that your microcontroller can work. Sometimes I need some specific controllers for that. So I can go for system specific circuits. Now if you remember the advertisement of inverter which was being played by Shah Rukh Khan, it used to say that this inverter is built with ASIC, application specific integrated circuit. So in that case, that inverter will also become an embedded system. And definitely the embedded system needs a processor. The memory is needed so that the code can be embedded in that. I've told you it needs a communication system. So there is a serial communication system. It is two-wire system, and it is universal asynchronous receiver and transmitter. UART, universal asynchronous receiver and transmitter. So friends, again there can be a question on this, and there will be an output device. So embedded system will take the input from the sensor. It will make it compatible with the processor. Processor will process it, and it will make it compatible with output device. And to coordinate all these things, I need a processor, I need a controller, I need a timer. So again, you can see the definition. What the definition says: embedded system is a dedicated system or specific function. So it gives a specific function. Your timer is giving the time limits. The software will give you the set of rules to be followed. In this way, my complete embedded system is defined. So let's see further what it is. So I have a processor. I've already told you about the processor. I can do the selection of processor based on instruction, what is the processing, what is the speed, algorithm, and many more things. I have many criteria to select a processor depending upon my application. If my application is very critical, I need a fast processor. If my application is okay, I have to take the data from the sensor, a simple processor will also do. So here is an example of washing machine. So input for this washing machines are buttons, outputs are motor and displays. It has a processing unit. That processing unit will be having a processor, RAM, ROM, and the software. So in this way, a complete block diagram is shown here, that it has some input, it has some output, it has some controller, memory, RAM, and definitely they are communicating each other with some communication system. So friends, till now I hope the embedded system is clear to you. Now there are three types of embedded system. One is small scale, medium scale, and large scale. So here just an example of small scale. They are microwave oven, washing machines, digital camera, refrigerator. Means they are not that critical application. They are simple application. So for such application, I can have a 8-bit processor and a simple software. Coming to the next, that is medium scale system. In medium scale system, there are multimedia system and voice recognition system. Now when I say multimedia and voice recognition, there is audio, video playing in the real time. So the way it is being shot, it has to be played back. At this time, I need a processor bit specific. So I have to include something which is called as digital signal processor. I may have to include a 16 or 32-bit processor. And the third example is LSS, that is large and sophisticated systems. Now in large and sophisticated systems, the examples are missile guidance system, aircraft navigation system, and hard real-time system. So they are very time critical. Means if the time is set that only in this much time it has to do the work, and it has to do the work in this much time. Now take an example of missile guidance system. So the moment it is given a command to launch, it has to take off. If it doesn't take off, what will happen? It may blast at the same place, and it may be a disastrous event. Now in an aircraft also, in aircraft navigation system, a delay of nanoseconds can create a disaster. So these are very hard real time. Hard real time means they are very time critical, whereas your small scale system are soft real time. Means if a bit work is delayed, doesn't make any difference. So in a microwave oven, instead of 1 second, if it takes 1.1 second, it doesn't make any difference. In the same as a washing machine or same as a digital camera. But in case of missile guidance system, 1 and 1 second can create a very large difference, and it can be a totally destructive event. So for your LSS, there should be a specific algorithm, a specific software, and a very time critical working microcontroller, and microcontroller may be of 1632 or above bits also. So these are the three types, that is a small scale, medium scale and large scale system. I hope friends this much is clear to you, and I hope you are writing all the points and you are enjoying the event. And friends, the next session, that is a session on Internet of Things, is more enjoyable. You will come to know what IoT and how it is playing an important role in a human life. So let's say one simple real-time application. Now friends, suppose the moment the lockdown is over, you will definitely, I know, you will go to party, and while doing a party, suppose you have a drink in your hand. Now it may be any type of drink, please don't take it in the other way. It may be a soft drink, it may be a hard drink, it depends upon you. Fine. Now when this drink is consumed, now this bench, this my table and the particular my glass, both are having some sort of sensors in it. Now you will say, why sensors? So what will happen? The sensor in the cup or the mug will sense the level of the liquid, and that will be transmitted to table, and from the table it will be transmitted to the what you can say, the chef, or to the waiter who is serving the things. So what will happen? The moment your liquid level goes down, it will come to serve another. So see how funny it is, and how you feel better with such type of hospitality, that you will come to know, array, in my cup, the moment in my glass the liquid is finished, before ordering the next is ready with the order. So it is a nice part of hospitality. So friends, I've told you, embedded system, apart from controlling, processing everything, it makes feel you better. This is what is the job of embedded system. So I hope this much is clear to you, friends. So you might have noted the points, and within some time I'll be starting with the next session, that is Internet of Things. Till then, take care and be ready for my next session on Internet of Things.